So permutations and combinations, yeah. Now, my suggestion is to forget these words, permutation and combinations, altogether. Okay. I don't like these words. I just suggest you forget these words. And there are three ways of looking at the problems that you get under this topic. Okay. So the first one is choosing. The second way is preparing. Okay. Or arranging. And the third way is tasks. Okay. So, and when you are choosing, the order doesn't matter. Okay. But when you are arranging, the order matters. And in tasks, it matters whether they are mentioning and or. Okay. We'll look at it from this point of view. So an example. So let's say this is about choosing 3 letters out of 5. Okay, let's say the letters are A, B, C, D, and E. Okay, so there are ways of choosing. If you're looking at the ways of choosing, it's N, C, R. Okay, so N stand. This is the definition of that. How to write it, how to calculate. So in this case, N is 5 and R is 3 because you're choosing 3 out of 5. So the final answer would be 5 factorial divided by N minus R is 2 factorial and R is 3 factorial. So therefore, this can be written as 3 factorial times 4 times 5. I always remember this way. So 3 factorial to 3 factorial cancels. This 2 factorial means 2. So 4 times 5 is 20 divided by 2 is 10. Okay. So the idea is that if you select 3 letters out of these 5, so something like this. So let's try to write all these 10. Okay. So one can be, say, A, B, C. Okay. And A, B, D. And A, B, E. And now you start with A, C, D. A, C, E. And now without B or C, you get A, D, and E. Okay. And then when you start with B, you cannot use any of the A's because they are already used. Okay, so let's go with B, C, B, C, D, and B, C, E. And you can also write B, E, D without C. Now B's and all A's and B's are used. So what's remaining is C, D, E. Okay. See, this is you can actually write it down, right? Now, let's do the same thing with preparing. When you prepare 3 letters out of 5, the order matters, okay? Now, in this case, the calculation goes as NPR, whereas the definition is n factorial divided by n minus r factorial, okay? So in this case, let's say, again, 3 letters out of 5, okay? So this is like 5P3, and that would be 5 factorial divided by 5 minus 3, that's 2 factorial. And this can be written as 2 factorial times 3 times 4 times 5. Therefore, the final answer will be 12 times 5, that's 60. So how did this 10 become 60? Right, let's pick one of these, a set of letters that we chose, right? So in this case, since the order matters, this simple ABC can be written in 6 different ways, okay? It can be ABC, it can be ACB, okay? It can be BAC, or BCA, or CAB and CBA. See that? The same thing, since the order matters, it can be written in 6 different ways. Now the tasks is like, there will be 2 directions here. And then O. So let's say if you are asking about task 1 or 2, you have to add them up. Let's say if it is, let's say task 1 has M ways of doing, M ways, and task 2 has N ways, okay? So the number of ways of doing task 1 or 2 is M plus N, okay? And the number of ways of doing task 1 and 2 is M multiplied by N, okay? Let's look at an example. So for example, you can say that, you know, how many ways are there for a man to dress up? Okay, something simple. So we will take the top, the lower clothing, and then the slipper and the belt, right? So let's say for the top, you can either wear a shirt or a t-shirt. For the lower part, you can wear either a trouser, a short, or jeans. Okay, slippers, you can find like let's say sandals, formal, and other informal. Okay, and the belt is either yes or no. So out of this, how many ways of dressing up? That will be, there are 2 ways of doing the top, 3 ways of doing the lower half, 3 ways of doing the slippers, and 2 ways of doing the belt, right? So that will be 2 times, 3 times, 3 times 2. Okay. But if they ask you, let's say slipper. No, this is not a very practical scenario, but just for our understanding. Okay, so slipper or belt. Situation. How many ways of doing this is like there are 3 ways of doing the slipper and 2 ways of doing the belt, so that the total will be 5. Okay, we will be doing a better example on how that and O works. But I hope you got the idea. When task 1 and 2, you have to multiply the number of elements, and when task 1 or 2, you have to add up. Okay, we'll be doing an example based on how many questions a student ticks out of what's given in the examination paper. Okay, wait for that. So you see that the best way to learn permutations and combinations, this is something I found much later, is just forget about the word permutations and combinations and just think of it from a practical standpoint. Okay, so another trick that I found, like when you are filling in blanks without repetition. Okay, so let's say filling in blanks without repetition with the letters. Okay, so take for example, you have letters A, B, C, and D, and then you have to fill up like 4 blanks. So the first one, so this is a task. So the first one, you have 4 ways of filling, and then since you cannot repeat, so this is more for choosing, and there are 2 ways of choosing, 3, 2, and 1. Okay, so this is 4 factorial that they're talking about. But what about if it is A, C, D with 1 letter being repeated? In this case, the final will be 4 factorial over 2 factorial. This is to account for that repetition. Okay. That is to account for that repetition. So let's say in this case, A, C, C. In this case, it will be 4 divided by 2 factorial and 2 factorial. Okay, and similarly, it doesn't matter how many terms are there, A, C, C, D, for example. This will be 6 factorial, 3 factorial, and 2 factorial. This is to account for repetition of A, and this is to account for the repetition of C. Okay. Now, let's do an example. Question 1. So, for example, let's say there are 5 men, and out of that, select 3, and then there are 6 women, and out of which we have to select 3 as well. So, how many ways of doing this? All right. So, this is a choosing, at the same time a task. Okay, so yeah, so the first, so out of 5, must select 3, choose 3, and so it's and, okay, so it's a task, and out of 6 you select 3, you choose 3. Okay, so this is like 5 factorial, 3 factorial, 2 factorial. This is 6 factorial, 3 factorial, 3 factorial. Again, I would like to write this as 3 factorial times 4 times 5. and this as 3 factorial times 4, like 4 times 5 times 6. Okay, so this to this cancels, this to this cancels. So what's left is 4 times 5 divided by 2 times 4 times 5 times 6 divided by, this is actually neglecting 1 is 2 times 3. This cancels, this cancels. So that's gonna be 10 times 20, and that's 200, okay? The next example, the last example, I promise to you, you will get like the task N and O together, right? So let's think about a situation where a student has to answer 4 questions for his exam. So you have 2 sets of questions, okay? So in each section, there's a total of 5 and 4 questions. Respectively, and the minimum number of questions that must be attempted is 2 for the first section, set A, and just 1 for the set. Okay, so let's say if the student is supposed to do 4 questions, okay, what are the different ways of choosing? So you can first look at either you can do 3 and 1, or you can do 2 and 2. Okay, 3 from set A and 1 from set B, or 2 from set A and 2 from set B. That's how you can fulfill the requirement of doing at least 1 question from each of the sets, all right? But in set A's case, it's 2. Now here, you can write 5C 3. And 4C1 plus 5C2 times 4C2. Okay, so this is 5, 3, 2 times 4, 3, 1 plus 5, 3, 2 times 4, 2, 2. Okay, and this is actually 10. The same goes here. This is 4, and this is 3 times 4 divided by 2, and that's 6. That will be 40 plus 60. That's 100. Okay. So what I suggest you do is do not consider permutations and combinations. Don't let it define by those big words, but look at it from a natural point of view. Okay, look at the questions from a very practical point of view. That is the best way to overcome this, the challenges of this lesson. Okay, that's all for this extra lesson, the e-lecture. We will meet on Sunday for our final class. All right, thank you so much.